So today we'll be looking at the dependency inversion principle. It is the D of the solid. So let's see a Cardstore which we were using in our factory method design pattern videos. So if you have not seen those videos, you might want to look at the factory method design pattern video from my design patterns playlist. So this Cardstore is creating cars of type Scorpio, Logan, Alto, Vitara and Etios. Okay, so this Cardstore is directly dependent on these classes. That is, within our Cardstore class, we are directly instantiating these classes by using something like Scorpio. Scorpio is equal to new Scorpio in our Cardstore class, something like that. But this can cause problems because in the next line, after instantiating Scorpio, we can call Scorpio dot drive or something, some method call we can make, and let's say tomorrow the name of the drive method changes to some other name, like let's say run or something, etc. So the Cardstore will be affected. So that's why it is better to create an interface in between. Let the Cardstore dependent on the interface. That is, it will say it will be directly dependent on car, and it will say something car Scorpio is equal to new Scorpio, and then car dot drive. So the interface remains same, and because our Scorpio is now implementing that interface, it is having an implement dependency on the car. That's why it must implement that drive method now. So this is a standard which both of them adhere to, something like that. So Cardstore is a high level component because its behavior is defined in terms of these low level components, Scorpio, Vitara, all these. So Cardstore basically creates these cars. So its behavior is creating these Etios, Logan. So its behavior is defined in terms of these lower level components. Okay, so that's why it is called a higher level component. So in other words, we can state the dependency inversion principle as our higher level component should not directly depend on the lower level components. Instead, both the lower level components should be dependent on the interface, as well as the higher level components also should be dependent on the abstractions. So this is an abstraction, and both the higher level and lower level components are dependent on this abstraction. So this acts as a standard in between. So this is the dependency inversion principle. Thank you, friends.